Welcome to another foss-north. I would like to start by thanking our gold sponsors, our silver sponsors, our base sponsors, and our partners from the community. Welcome back, everyone. I hope you enjoyed the break. So the talk with Marta will be pre-recorded, but she will be here for the Q&A. And as I understand it, she's also live in the YouTube comments if you have questions. So please enjoy.
Good morning, good evening, good afternoon, no matter where you watch this presentation from. My name is Marta Rybczynska and I'm a founder of Subsystem, an open source centric company, and I have been working with big open source code bases for the last 15 years. During that time, I have seen a lot of approaches to entering the code you do not know, and I would like to share some of those experiences with you today. It's foss-north, so I had to start with some penguins. However, we are not going to have a trip to a penguin land. In some way we will. But we are rather going to a jungle of the Linux kernel. And today we are going to learn how to write a Linux kernel driver for any subsystem you choose. When you think about adding to an unfamiliar code, what do you feel? It feels like a jungle, doesn't it? There is some excitement about learning new things. There is some fear because there may be strange beasts hiding somewhere that you cannot see. And there's a lot of things you can look into, you can watch. When entering unknown code, I could notice a number of ways people react. Some of them just freeze in panic, and they do not advance because they do not know where to start from. Some other people start reading everything they can find about the subject. They read all the project's documentation. They read all the specifications they can find. They read all of the examples they can locate. That can take a week, 2 weeks, 3 weeks, or even more. Some other people just start playing with the thing, even if they do not understand it quite well, and they try to find something working. Those are different approaches. Today, I'm going to show you my personal approach. You may have a different one, and I'm going to share with you how I enter a new code base. This has been proven helpful. So let's start. For the presentation of today, I wanted to work with an example. However, when you look into Linux kernel programming, there are quite many examples, in fact. You have books, you have online tutorials, and quite often they cover a character driver. That is easy, but that didn't seem to be something I would like to cover. I preferred to have something a little bit more complex I started thinking about a network driver. Ethernet is something I know very well, so it didn't seem that right to start with something I know very well. I decided to go for a Wi-Fi driver. I've never wrote one myself, so that could be advantage. That could be an adventure for me too, right? Let's look into the Wi-Fi land. That looks like a forest, doesn't it? So first, let's have a look of what we can find around the place when we start a Wi-Fi driver. Most of you will start with an online search about an example driver. I would do that too. It's always interesting to find out what shows up. We can also check the kernel documentation about the driver model. We can check the kernel source code about the drivers using the same type of functionalities. And we can start our plan from this point. We'll cover the first point in a moment. Let's look into what is there in the kernel documentation. First, we do have the driver API documentation, which is quite detailed. We have a documentation of the data structures, callbacks, different fields, what they mean, and how you're going to model your hardware to the driver. And the moment when we'll be in the hardware side of things, when we'll be addressing some specific hardware, that is very, very helpful because we can find the way to represent the hardware features. However, I find that this part of the documentation is quite hard to read as an introduction. However, it gives us a little bit of the information needed from the beginning, which is that there are two models of Wi-Fi drivers. I'm not going to dig deeper into that just today, but that's an important piece of information we need when entering the Wi-Fi drivers. The other interesting part of documentation I could find is the Whereas Wiki, which is more user level. We have a glossary of the most important terms, very useful when you are just entering the drivers, just entering the Wi-Fi drivers, and you do not know what all those abbreviations just mean. It also has a list of drivers and their status that may be helpful when looking for a driver that resembles the one you would like to write. And it includes information about user-level tools, a list of projects and tools you can use to deal with Wi-Fi. All that very useful. But we do not have an example driver right there, don't we? So, let's now look what we do have inside the kernel. And we do have a little problem here. The wireless drivers are in drivers net wireless, and you have a number of them I give you an example of the content of one of them, chosen at random. This is a complete Wi-Fi driver, and what we have here, it's 13,000 lines of code, more than 300,000 characters. All the drivers, with some little exceptions, are quite similar. This is a little bit complicated to understand, don't you think? If we were to use that driver as a base of ours to learn about how to write our driver, this could be a little bit complicated to understand, especially that we have to understand that specific piece of hardware too at the same time. So we do have a little problem here. We do have the documentation in the kernel. We do have existing drivers that do work, but most of them are really, really complex. So what to do? When you are starting writing your driver, you do have two paths to it. And both solutions have their advantages and their inconveniences. The first one is starting from an empty file. And then you start adding one function at a time, and you build your driver this way. What happens in practice? That it rarely happens without the copy and paste from other drivers, because you are looking for a specific functionality, you find it in another driver, and then, well, you just copy and paste it, right? The disadvantage of writing a driver from an empty file is that quite often the debugging is going to be quite long, because you may be just missing a little bit and you don't know what you are missing. It means that you will be trying to find out why it doesn't work for some time. And finally, you may know that the Linux kernel internal APIs, contrary to the external APIs that you use in applications, the internals API do change. It may happen that you start writing your driver and you choose an obsolete old API when there is a newer one that is more appropriate for a new driver. This happens when looking into other drivers. You may start being inspired by a driver that is in fact quite old and it wasn't changed to use the new API. There is a risk here, and it may happen that after writing your driver, you will have to rewrite it with a new kernel API. This is what happens when you start from an empty file. You can also do it differently. You can start from an existing driver. The advantage is that you are modifying existing working code. So we could expect that it's going to work and all the changes are by you. If you break it, you should be able to find out rapidly. In this case, you may go through multiple refactoring phases. You change the driver according to your needs, with using different phases, making it work after each phase of this refactoring. The disadvantage we can find using this way is that you will have to understand the code. Understand the basics of the driver you are modifying. It's better if you know the hardware you are taking. If you understand the hardware of the driver you are taking. And it's easier if the driver is smaller. Right? So if you are choosing this approach, it's more important to choose the right driver you are starting from. Right? You need to choose the right driver you start from, because otherwise you may run into the same type of problems. Like in the first case, you were inspired by the driver with old API, and the same thing happens here. You may have started with a driver using older APIs, and then again there will be things to change. The tutorials for writing Linux kernel drivers usually use the first approach. What I'm going to do today, I'm going to use the second approach. So let's get started. Our first step will be working with an example driver. I've told you before that one of the things we can do when starting looking for information about the new subsystem would be to find an example driver online. Not necessarily one that is in the kernel, but one someone wrote for some reasons as an example, and start working from that. For the Wi-Fi, I did find a blog post explaining how to write a Wi-Fi driver. The blog post is quite long, quite detailed, explaining the structures the author uses, and there is a source code repository related to the driver. So, we can try to look into this one. But before we do it, I would like to share with you one secret recipe. I'm using this table to look into a driver to find out if it's a good candidate to use in my projects. And I invite you to reuse this table or maybe extend it for your own projects. Let's have a look at the categories. First, we have the license. If I'm going to use a third-party driver, it has to have a license that is compatible with my project. If it's a personal project, usually it doesn't matter much. If you are doing a project for a company, you're working for a company, or you're contracting for a company, this has way more importance. You need to have a driver with the right license. Then I try another check with CheckPatch, a tool that is verifying if the patch or a source code file is correct in terms of formal structure, if the coding style of the file is right. The coding style gives us some insight if the driver is close to being upstreamed, or it's some development that is quite far from it. We would expect the coding style to be clear, to be clean, and to be close to what is expected in Linux. Then the third question, is the driver maintained? Here we can use a few things to find out. We can look for the number of commits and where the last change was made. Is it used? We can find traces of the driver being used by different people, but we can also look at the number of patches to the driver and the number of authors. More authors usually means that there are more people using this driver, right? And then 2 last questions. Does it compile? Quite obvious, but for the drivers that are not included in the Linux kernel, as I've told you, the internal APIs do change. If you take a driver that is a few years old, it may happen that simply it doesn't compile with your new kernel, or it doesn't compile with your distribution kernel. So this is definitely a thing to check, right? And then I do verify if the driver works. For this, I use a test list every time. I define what needs to work in a driver, so I could define it as working. For a Wi-Fi, it would mean that I'm able to see the network interface, that I'm able to see the access point for Wi-Fi, that I'm able to connect, and I'm able to send and receive some packets. That's the minimum, and we can have more. Ideally, for each driver type, we'll have some tests written in a scripting language or reusing a test framework, so we can test and see if the driver works. Let's check what it all gives for our first example driver. So, first the license. We can find it in the file, it's all fine. Then we go to check batch, and then we have a surprise. 100 errors for 400 lines of code, that is much, right? So I looked into the details, and it wasn't hard to find. It's mostly the formatting errors, pretty simple to fix. We can fix them without problems, but it gives us an impression that the author didn't run check patch over the driver, what is surprising a little bit. So I'm marking this in orange as something that it's not discriminatory for the driver as is, but it is a warning sign. Then we are going to check if it's maintained. And then for this driver, it has just 2 commits in total, and the last was 2 years ago. So it was just committed at the beginning and nothing happened. So we can say it's not maintained. Is it used now? Not likely, because it's an example driver. And does it but we are going to continue, right? Does it compile? And so that was a big surprise for me. Driver for 2019, and it did compile with my mainline kernel. I was surprised. I was expecting there would be things to change, and no, it did compile. So I thought to myself, okay, it's not exactly what I was searching for, but we can start from this driver. We can start playing with it, and we can start learning from this driver, because it is expected to work, doesn't it? As it was published. So, does it work? Well, partially. And let's look into the details. My first test is loading and unloading the driver. So we do it with insmod in this case, with doing a mod prop of the driver that is required. And what happens is that I get absolutely nothing in the kernel log, so I started looking, and it seemed that it has loaded correctly. However, I do prefer if a driver writes something in the log when it's loading, even if it loaded just fine. Then my second test is to loop removing the driver and inserting it again. There is a common problem in the drivers that the structures are not correctly removed when removing the driver. So it's a common source of bugs. So let's try to remove it and insert again. And in this case, it's passing just fine. So we can continue. Now let's look into the network interface. In the source code, we can find out that it's going to be called Navifly, and it does exist in my system after I load the driver. The interface is up, and the settings look quite reasonable. The only thing I'm a little bit surprised with is the zero MAC address link level addressing. But okay, it's not that important for an example drive. So far so good. Now, the Wi-Fi status. This is something we are going to do with some user space commands. Those we can find when looking into the documentation and learning about user space, command line, Wi-Fi tools. We can list the driver. It is showing a number of information about the channel frequency. Okay, the keys and the encryption keys are off, but we do have the Wi-Fi network name. And well, if we list the Wi-Fi networks, we can find that there is something. However, we have burst at 0 and we have signal at 0. So as if we had a network that does not really work that well, but we do have a network. So I'm going to try to connect. So we can connect from the command line with a command like this. And what happens? That. Connection activation failed, IP configuration could not be reserved, not available addresses, timeout, etc. So what could it mean? I've never seen that error message before. So I started looking, finding out if there are some packets getting in and out. And then I came back to the driver's source code to confirm what I was thinking about it. I didn't tell you before that when looking in the driver source code, I found some part of the code that looked a little bit strange to me. And let's have a look. This is the function that should be run when the driver will try to send a packet out. What you can see just there is that we have key free. So we are freeing the packet just there and returning that everything is just fine. Absolutely nothing happens with the packet. It doesn't get sent anywhere. So basically my timeout comes from the fact that it cannot connect because the driver is not sending anything anywhere. Now, a little bit of explanation of what has just happened in there. There is a difficulty when writing Wi-Fi driver because you have to connect somewhere. And for Wi-Fi, it's not trivial. You cannot easily do a loopback device. So the person writing this example driver decided to just finish the example here. What makes a perfectly working example, but it's not going to be interesting for my task to having a driver I can use to send some packets. I could have gone further with the driver, adding the new functionalities in it, but that would be writing those functionalities from scratch. With this driver, sending and receiving packets will just not work. We need then to look for other solutions. And in fact, this experience has nothing uncommon when you are taking drivers coming online from different sources. It may happen that the example driver is not exactly what you are looking for. It may not include the functions you want. So we learned quite many things with this driver. And let's look for some better example. This time we are going to come back to the mainstream Linux and have a more detailed look, to locate something we can use for our example driver. I found two drivers that we can use. The hardware simulation, you have the descriptions coming from the key config that the hardware simulation is simulating a network. Okay, that could be interesting. And the second driver, a virt Wi-Fi, yet again a virtual driver, that adds a Wi-Fi driver that is wrapping up an Ethernet driver. That looks interesting. I really wanted to use the hardware simulation driver in this example. However, it doesn't really fit this tutorial. I find this driver very interesting, but that would be another project. Instead, I've chosen the virt Wi-Fi because that's more or less what we need. A driver that is working. In my case, it has Ethernet that I know, so it would be easier to work between the Ethernet and Wi-Fi. But before we enter the driver, we come back to my checklist. This is the version for an in-tree driver with just one additional question. Is it enabled by default? And is it a distribution default? Not all drivers in the kernel are maintained at the same level. There are drivers frequently used that have very high quality, and there are drivers that are used less often by less people on specific platforms only, and we can expect that there will be more issues if we try to use them. This is where this question comes from. Now, let's have a look at the answers for my table. The license, it's okay, check patch. It's quite okay. This one warning is nothing special. However, the driver is not enabled by default and it's not in my distribution, Debian. So it's not that frequently used, it seems. Is it maintained now? We can find from the history that it has been added in November 2018, and since then it has had 11 commits. Last of them was in March. Not that long ago, so it looks quite good. And then we can find commits from 7 different persons. That's not that much, but for 11 commits, that's okay. Does it compile? It does. And does it work? Yes, it does. This time, I'm not going to cover all of the commands used to make the driver work. I'm just going to cover one thing. This driver is wrapping an Ethernet device. So there should be a way to tell this driver about the other interface it should be using. The thing is, I started looking into the source code and I couldn't find a command explaining how to use it. There was no information in the kconfig neither. So the other thing to have a look is to look into the commit messages. And the first commit message of this driver, it's giving us exactly that. How to use it, how to wrap the driver, how to use the driver with an Ethernet interface we have. So I used that and it worked. In this case, what we get when we list the Wi-Fi's, we get something like that. So we seem to have some signal and some bars, so it looks like a Wi-Fi. And then we connect, and it does really connect. So we do have a working driver that we can use in a system without Wi-Fi. And we can start working from here. So now, how to make your own driver from an existing working one. Here's how I do it. In this case, I've split the Wi-Fi part from the implementation, in this case, the Ethernet. And then after you have that split, you can be replacing that specific implementation with your new implementation using your own hardware. And then after that, you can come back to a single file if you want to, or as refactoring. I'm building the driver as an out of tree module because it's way easier to compile and load a separate driver than trying to compile the kernel source. The modification is simple. And I'm keeping copyrights of the original file in the source code. And I note from which file it comes from, because we may be renaming the file later on. So I want to keep the information about what source code we started using for our new driver. Refactoring is an art. How I do it, I do the first commit with my Git repository with the original source code, and I add the out of the tree build. Then I can do differences from this point. Then I do one functional change at a time, and after functional change, the driver has to compile and it has to pass tests. Then I commit. The difficulty is in the first split, right? It takes time, it can be complicated, but it doesn't have to be perfect. You split, and then you can refactor further how you solve it. Because after each step of refactoring, you will know more about the driver. And here's an example of how it looks like after 2 steps, in my case. I do have a makefile, I do have the header file with the common definitions of the data structures that are shared between the 2 parts of the driver. Then the main part is the Wi-Fi port, and the Ethernet port is the Ethernet part of the driver that we will be replacing later by our new implementation. You can see that those ports are of similar size. There's more or less the same size of the both parts of the driver. And an example simple makefile for an out-of-tree build. As you can see, pretty simple, but works. And we are just fine with it for our example. Now, after you have the driver split, you have created an interface between them. You can start adding your own source code and starting to create a new version of the driver with your own hardware. This part, depending on your hardware, will of course have some specific parts that you will have to figure out yourself. But the advantage of this approach that you will be modifying something that works. And you will be able to look into the original driver we took to try to figure out what this particular function will be doing. During this part of adding new code, you may find out that the refactoring was not ideal, and you may want to redo the refactoring a little bit. That's normal. I've done that. We can be changing the split between the 2 parts of the driver also later on. I hope that with this presentation, you have an idea that there is a path in the jungle. There are ways of approaching writing code for a big code base like Linux, but I think that this methodology works for any big source code, be it an operating system, be it a compiler, be it a big library. You can use the same way of approaching finding out information. And at the end, a few of takeaways for you. First is that you can find a lot of online resources. And the first thing I recommend you to do is to check the date. If the resource is very old, it may have outdated information. So it may require you to dig deeper to find out what the current situation is. Sometimes for the Linux kernel, detailed documentation of certain parts is missing, and you may have to take the source code as documentation. And then finally, if there are official resources, they're usually quite high quality. So I'm using the official resources as the first information source. If they do not include the information I need, then I will be looking somewhere else. My second takeaway is to try to have a functional code as early as possible. I have been working from zero a number of times, and it may be frustrating because it doesn't work, and it doesn't work, and you just don't know why. And it may be that you are just missing one single line in your whole driver, but it may take you time to figure out why. Also, over the years, I've learned to run tests every time on every new version of the driver. Because if I make a mistake, I prefer to find it earlier than later. You can say that I'm using a test-driven development for kernel drivers, and that's true. Then, if you follow the refactoring path, your first refactoring won't be perfect probably. So I'm working on a separate Git repository, and then you can do things. You can fold patches, you can redo your refactoring differently later on until you get to your final version. So we do have a path in the Django, don't we? Before we come to the questions, I would like to thank the authors of the photos I'm using in this presentation. We will be ready for questions now. We have like 15 minutes, so we should be fine. And I'm ready to take your questions or your comments about this presentation. Thank you.
Thank you, Marta.
Thank you.
So we've collected a number of questions from the side here. I think Tobias has them at hand.
I do. Thank you for a nice presentation. It's lovely to see. All right, so the first question was, if I wanted to get into kernel hacking, what would be a good starting point? What would you recommend? I mean, you mentioned that there are a lot of character drivers, so maybe that would be the easier point instead of a Wi-Fi driver. I don't know. I'm not that into kernel hacking. So.
It depends on the person. If you already have experience in some area, for example, working with hardware, or you have theoretical experience with scheduling or memory management, that would be the good place for you to start, because you understand what the developers will be talking about. If you do not have any specific experience, I would recommend to find a subject that interests you. You can start reading about the kernel development, for example, and if you find something that interests you, something that you find cool to work on, then you can start working on it, preferably with a small patch first, of course, and then working on bigger things. They are also, in some kernel sub-projects, there are list of tickets that are ready to be taken by people who start. So if you are in a specific subsystem you're interested in, you can ask the developers, or you can find yourself out if there is that list of tickets for new people, and you can start working on those. Typically, if you ask about the guidance, the work you want to do, you will be well welcome, and you will get helpful information.
Oh, yeah. That sounds great. It sort of makes my second question here moot, but I'll do it anyway. So do most subsystems have like driver APIs that are reasonable, or are there any areas of the kernel that one should steer clear of because they might be too intimidating?
I'm a wrong person to ask this question because I'm a type of a person who exactly enters into the areas of the kernel other people find intimidating, because I like to understand what is happening. They are quite some drivers where there are just a few developers. And those places may be harder to get into because they are talking to each other with their own language. The commit messages may be also in their language. So even if it's in English, it may be complicated to understand. One example of that is BPF.
Oh, yeah.
Quite a popular topic, but every time I look into the code, I find it a little bit complicated, but it doesn't mean you cannot understand it.
Okay. And maybe following up on that, are there any specific subsystems that are especially easy to get into, like that are especially well documented, for example?
That's a very good question. Of course, I do not have experience with every single kernel subsystem. That would require a few lifetimes. I have been working in the NVMe subsystem, so the flash drives, and the community is very friendly. I've seen very good reactions to first patches from people in there. There is documentation, there is open specification. So if you have something to add in there, it may be a good start, especially as the hardware is becoming popular. So you have something to work on.
Oh yeah, it's a hot area. Yes. All right. Those were all the questions I had on my end. Do you have any to add, Johan? I don't think we got any more from the...
No, from my side, it's empty on all channels now. But big thank you for your presentation. Thank you.
Well, thank you very much. Welcome. Bye.